Good morning, I'm Timothy Precella. Today we're going to finish up this Math 13-14 final exam review sheet. And I think we're almost finished. We're ready to start at number 31. We've done 1 through 30. We're ready for 31. And let's see, it says use properties of logarithms to expand the logarithmic expression as much as possible. Where possible, evaluate logarithmic expressions without using a calculator. And you know I'm a big writer, so I've already rewritten the problem over here. Let me make sure that's what the problem actually says. Log base 8 of the 5th root of 17 divided by y squared x. Yes, that's what the problem says. So I think I was very consistent. When I was expanding logarithms, if I saw a radical, the first thing I would do is I'd rewrite that as a rational exponent, 17 to the 1/5, all over y squared x. Once I've gotten there, we would combine those first three properties of logarithms in one single step using the product rule, quotient rule, and the power rule. So I'd look here and I'd ask myself, how many separate logarithms will I have? How many distinct factors do I have in this argument? Three. I have one on top, two on the bottom. That means I need three logarithms. So I'd come over and I'd write my log base 8. Log base 8 and log base 8. And then I'll get us started. The first factor, that numerator, is the 17 to the 1/5. The 17 is the argument. Using the power rule of logarithms, we bring down that 1/5. That becomes the coefficient. When we're expanding logarithms, we write them as a series of sums and differences. So with that in mind, what sign are we going to have connecting these, the first logarithm and the second logarithm? A minus, because we're moving down to the denominator. The argument is a y. Where does that exponent 2 go? In the front. Okay, it becomes a coefficient. Next sign, and it's another minus because y is also in the denominator. We have a argument of x, coefficient 9. It's just an assumed 1 because there's no exponent on x. Remember, the product rule of logarithms says that if you have a product, you can rewrite it as the sum of individual logarithms. But this thing here should not be a plus. It's a minus because, remember when we were going through doing this, showing each step, the minus that you pick up from that fraction bar has to be distributed over each logarithm. So don't make the mistake of thinking that this thing here is going to be a plus. Any factor that's in the denominator will have its logarithm will be preceded by a minus sign. And when we look at the possible answers, A, B, C, or D, let's see. A, B, C, or D, B. 1/5 minus 2, yes, I agree. With response B. And the next one, number 32. Same instructions for expanding the logarithm. So I've written the recopied the logarithm. The first thing I'll do, I was very consistent all semester long. When I ran into a logarithm that had a radical, I'd rewrite it using an exponent. So that's the common log of, we have a 7x squared. That cube root of 1 minus x, how will I write that? I agree. 1 minus x with a 1/3 exponent. We still have a 4 times an x plus 1 quantity squared. How many separate logarithms will we need? How many distinct factors do we have in this argument? Let's get started. Let's do the numerator first. How many distinct factors do we have there?
3.
3. 7 times x squared times 1 minus x to the 1/3. So there are 3 distinct factors on top. How many on bottom? 2. 4 times x plus 1 squared. So that's 2. That means we need a total of 5 logarithms. Okay. 1, 2, 3. I'm going to have to spread it out like this. 4, 5. What's the first argument?
7.
Just a 7. Notice there's no exponent on that 7. Why don't you call it out to me now from left to right? Now, we start off with a log 7, plus or minus, plus. Do we have a coefficient? Okay.
X.
Log x plus, oh, 1/3. I'm going to have to squeeze that 1/3 in there. I'll put it in red. 1/3. That way it'll stand out. Maybe not. Argument 1 minus x. So remember, if your argument contains addition or subtraction, you have to enclose that argument in parentheses. Minus, we're moving down to the denominator. Do we have a number here? No.
4.
Log 4, okay. Plus or minus? Minus, do we have a number here?
2.
2, I agree. Log
X plus 1.
x plus 1. And okay. Log 7 plus 2 log x plus 1/3 log 1 minus x minus log 4 minus 2 log x plus 1. Looks like I'm getting response A. Any questions there? Y'all were just taking your test over this 2 weeks ago, so it shouldn't be that distant in your memory. So hopefully it's still fresh on your mind. Number 33, use properties of logarithms to condense the logarithmic expression. Write the expression as a single logarithm, its coefficient is a 1, and when possible evaluate the logarithmic expressions. Now we're going backwards, we're condensing the logarithms. To condense logarithms, first of all, let me make sure I've written the problem down correctly. Log base x of 4 plus log base x of 2. When people come to my office and they're stuck on a homework problem, they can't get the correct answer. My math lab keeps saying that telling them the answer's wrong. The first thing I do is I say, okay, let's make sure you didn't miscopy the problem. 9 times out of 10, that's it. Problem is just miscopied when you wrote it down on a sheet of paper. So anyway, what I would do to condense logarithms, I'd write my log base, whatever. I think what I would ask first is, do I need a fraction bar? No, because
It's on addition.
okay, the logarithms are just being added, so we don't need a fraction bar. So what are we going to do to the arguments? We're going to multiply. So we have a 4 cubed times, what else do we have?
2.
A 2. And there's no exponent on the 2 because there's no coefficient in front of log base x of 2.
120.
4 cubed is a 64. Times 2, I agree with 128. I didn't really need those brackets. I could have just written it as log base x of 128. I'll write it like that. And let's see. Looks like it's another response. Where is it? A, right here. Log base x of 128. And number 34. 34 looks messy, so let me make sure I didn't miscopy the problem. 3 log base 4 of 2 plus 1/7 log base 4 of r minus 6 minus 1/2 log base 4 of r. I'd write my log base 4 notation and then ask myself, do I need a fraction bar?
Yes.
Yes. Okay. It's because of the minus sign. So my question is, which minus sign? Which minus sign says we need a fraction bar? The one in front of the one that's not inside the parentheses, the red one, the one that's in front of the 1/2. That's the thing that says we need a fraction bar. That sign inside the argument has no impact. We're just going to be stuck with an r minus 6 in our final answer. So here goes. What have we got on top?
2 cubed.
Okay, a 2 cubed. That's where you're getting that 8. What else?
R minus 6.
R minus 6. Okay, I'll write that in a second step. Okay, but you're right. It'll be an r minus 6 to the 1/7. That's the same thing as the 7th root. Anything else on top? No. On bottom? Okay, an r to the 1/2, which is the same thing as the square root of r. So 2 cubed is 8. R minus 6 to the 1/7, I'll write that as the 7th root of r minus 6. And r to the 1/2, that's the square root of r. For my final answer, oh, and let me see, let's look at, let's see, this is number 34. A, B, C, or D?
C.
C. Looks like C is the only one that comes close. Number 35, solve the exponential equation. Express the solution set in terms of natural logarithms. So this is number 35. Oh, there it is. Solve in terms of ln. So we'd introduce a natural log on both sides.
They canceled out on the left side.
Okay. The natural log of e, some of my students yesterday in the Tuesday-Thursday class were just wanting to bring down the x plus 4 times ln e, but remember the natural log of e, those are inverse functions. When they're performed consecutively, they just undo each other, leaving you with whatever that exponent is, just an x plus 4, equals the natural log of 2. And now, oh, it's that invisible orange ink. Okay. There, that invisible orange, there. It's not really better, but there. So, all we need to do to get x by itself is minus 4. Can we subtract the 2 and 4? No, of course not. We're just stuck with the natural log of 2 minus 4. Now, when you were doing this in your homework, the homework required that you punch that into your calculator. Here, you're given the answer in terms of ln. Looks like response D, ln 2 minus 4. And another one. This one looks really messy, number 36. So let me make sure I didn't miscopy it. 4 to the x plus 4 equals 5 to the 2x plus 5. We had another method of solving exponential equations. The other method was to introduce to get a common base, but I think we can look here and tell clearly 5 is a prime number. The only prime number that divides evenly into 4 is a 2. 2 certainly doesn't divide evenly into 5. So getting a common base, that method just falls apart. So we have to introduce an ln on both sides. And then that lets us pick up the x plus 4. We pick up the x plus 4. Move it down times the natural log of 4 is equal to, pick up the 2x plus 5, move it down times the natural log of 5. Now what? Distribute the ln 4 over the x plus 4. That'll give us x ln 4. Don't get fancy. That doesn't become an ln with a new argument of 4x plus 4 ln 4. Remember I said as we were going through these problems that what you expect, the way we stuck an ln in front of 4 and an ln in front of 5, your answer should just have ln 4s and ln 5s. It shouldn't have ln 20s. It shouldn't have ln 1s. It should just have ln 4s and ln 5s. Here, distributing
2x ln 5.
2x ln 5.
Plus 5 ln 5.
Okay. And I'll get all the x terms on the left side. I'll pick up the 2x ln 5, move it to the left, so we have x ln 4 minus 2x ln 5 equals, on the right side we have a 5 ln 5 minus 4 ln 4. I agree. And now what? Why did we get those x's on the left side? So we can factor out the x, that common x we're factoring out. And what have we got left inside those parentheses?
ln 4 minus 2 ln 5.
I agree. ln 4 minus 2 ln 5.
Then divide it.
And then divide. That's x times that. ln 4 minus 2 ln 5 is a messy decimal number. X times a number, to undo that multiplication, we divide. To give us x equals, let's say 5 ln 5 minus a 4 ln 4 all over ln 4 minus a 2 ln 5. And let's see. So moving that up. Oh, let's see, where are we? We're down here, way down here. 5 ln 5 minus 4 ln 4 all over ln 4 minus 2 ln 5. Can y'all see that? Response D. Any questions there? And some logarithmic equations. Number 37. Well, first of all, solve the logarithmic equation. Be sure to reject any value that's not in the domain of the original logarithmic expressions. Give the exact answer. When we were solving logarithmic equations, we didn't have to punch the things into our calculator to get answers like we were doing with my math lab and these numbers up here. So they're saying that you don't have to punch the stuff into your calculator and round, but we knew that already. What are they trying to say there? Be sure to reject any value that's not in the domain of the original logarithmic expressions.
That makes it a negative.
Okay, remember the arguments that we're looking at. The thing that follows the logarithm can't be a negative. So whatever you get for x, you're going to have to plug it back in and make sure that each argument stays positive. So number 37. Number 37. Here goes number 37. Solve the logarithmic equation. Be sure to reject any... I've already read that. Let me just make sure I didn't copy the problem down wrong. Log base 4 of x plus 5 minus log base 4 of x plus 3 equals 4. So, when we're solving a logarithmic equation, we would try to get the equation in the form one term equals one term. The most desirable form was one logarithm equals a number. We already have equals a number. We have that 4 by itself. So what can I do? We already have the 4. What can I do to the left side? Or how can I rewrite it so that it's in the desired form? One logarithm equals a number. We're going to have to condense our logarithms, and I agree. We're going to have a fraction here because of the minus sign there. Okay, so it's an x plus 5 over an x plus 3. Give me a moment here. This is green. Well, I guess it's blue-green since it was blue, and then it really looks black, I suppose. Well, okay. And this is blue-red right there. We're going to cancel out that log base 4 using the inverse of log base 4, and that's going to turn all of this stuff into exponents. The base of the exponent will be, but which one? The green. What determines the number you put down here? Okay, it's going to be a 4. Okay, it's the base of the logarithm, the red 4. That could have been a 3 there. Okay, it's this number that you use in order to have the inverse functions perform consecutively, and they cancel each other out. It's this base right here. It's this 4 right here. So all we have is x plus 5 over x plus 3 is equal to 4 to the 4th. Is that 256? Now what do you think I'll do?
Multiply by the common denominator, x plus 3.
Okay, good. That's what I'm going to do. Multiply x plus 3. The left side reduces very nicely just to
X plus 5
equals
256x plus 768.
256 times x plus 256 times 3. I agree with 768.
Subtract x from 256.
Okay, so that gives us a 255x. That means we're going to have to move the 768 over to the left. What's that going to give us?
Negative.
A negative 763. I agree.
And then divide by 255.
Divide by 255. I agree. To give us x equals negative 763 all over 255. And if I remember correctly, that's a little bit, that's approximately negative 2.99.
Yes.
But I'm not going to use that negative 2.99 for anything other than the checking process. Negative 2.99 plus 3, is that positive?
Yes.
Yes, it's positive. Negative 2.99 plus 5, is that positive?
Yes.
Yes. So this negative 763 over 255 is an acceptable answer. I only used a decimal approximation because it helped with the checking. But the answer they're looking for is negative 763 over 255. Let me push this up. Negative 763 over 255. That looks like response D. Any questions there? Do I have the whole thing? Yeah, there it is on the whole thing on there. Whatever that base is for the logarithm, that's what you use to cancel out that logarithm. That's what you use as the base of the exponent. So number 38, I think this is our last one. Let me make sure I don't miscopy the problem. Log base 35 of x minus 70 equals 3 minus log base 35 of x. Okay. There's really only one sensible first step. What is it?
Get 3 by itself.
Get the 3 by itself. We're going to try to get equals a number. So we'll pick up this logarithm, the log base 35 of x. We'll add it to both sides to give me log base 35 of x minus 70 plus log base 35 of x is equal to 3. And, oh, I'm moving up too far, aren't I? Okay. So we now need to write these two logarithms as a single logarithm. Here's my log base 35. Do I need a fraction bar? No, but we have a minus. Why don't we need a fraction bar? It's inside the parentheses. You don't look at the signs inside the argument. It's the sign connecting the logarithmic terms. That's a plus, so no fraction bar. What are we going to do to x minus 70 and x? We'll multiply. I agree. X times x minus 70. And now what?
Distribute.
Okay, but I'm going to wait to distribute until I...
Get rid of
increase to the 30.
Okay, so I'm getting rid of that log base 35. Okay. And then I'll go ahead and distribute, and that'll give me an x squared minus 70x equals 35 cubed. And I seem to have misplaced my calculators. 42,875, 42,875.
Yes.
And this is quadratic, so we're going to get this set equal to 0. So we have x squared, let me get a different color here, x squared minus 70x, that becomes a minus 42,875 equals 0. So I'm going to write my two sets of parentheses, and this isn't as bad as you might think it is because of the multiple choice format. We know x squared. We know that that's going to be an x times x. What do we know about the signs? Okay, that negative sign there, that last sign's a minus, so we have one plus and one minus. And now, let's look at the possible answers. When you're looking here, when you're looking at this equation, it's obvious that eventually you're going to have to set each set of parentheses equal to 0. And so the numbers that appear here are going to be part of the possible answers. So let's look and see. Which one of these numbers will divide evenly into 42,875? I think 245 goes in evenly. If you punch into your calculator 42,875 and divide it by 245, I believe you get a 175. I know that just because I remember from doing this problem in the Tuesday-Thursday class yesterday, okay? And I think it was on your third test review anyway. That's another reason why the numbers seem familiar to me. But what's the difference? If you subtract these numbers,
70.
you're going to get a 70. That's what we need there. So what should go after the x plus? The 245 or the 175? Remember, we want the outer and the inner to give us a negative 70x. So what did you say? Okay, so the 175 and here a 245. And if you check a negative 245x plus 175x, sure enough, that gives us a negative 70x. Set each factor equal to 0 to give us a negative 175 and a positive 245. And there it is, right there. So we need to check, is negative 175 okay? No, negative 175 minus 70 right off. That gives you a negative result. So cross out or discard negative 175. What about 245? 245 minus 70, is that positive?
Yes.
245, is that positive? Yes. In most cases for logarithmic equations, the negatives won't check and the positives will, but that's certainly not always true. So if we had gotten 50, would that be okay? 50 is positive. No, because 50 minus 70 is not a positive argument. So, but in most cases, if this were a game in Vegas and I were betting, then I would always bet the positive checks and the negative don't check. So, and I'd walk away with more money, depending on what the odds are established by the casino, I suppose. Response A. But now if 245 had it divided evenly into 42/875, I would have gone to the next one, 25. I would have kept on going until I found one that divided it evenly, and the difference was that 70 that we needed. Question.
Have you been to Vegas?
Many times.
Yeah.
I had to quit going. I just gained too much weight. And my luck was always at the tables, the buffet tables. So, no. Yeah, well, I was never really fond of losing money. Well, okay, let's see. Is that it? That's it, okay? So let me turn this off, okay? I'm turning this off. Bye-bye. We're through with the review sheet.